Hello and welcome to all students. In this lecture we discuss about the ordinary discontinuity, or we can say that a discontinuous function of the type first, or first kind of discontinuity of a function. So first of all we define what is meant by ordinary discontinuous function, or which function has ordinary discontinuity. Okay, so let us write the definition of ordinary discontinuous function. A function f of x is said to have ordinary discontinuity at x is equal to c if both limit f of x extends to c minus and limit f of x extends to c plus exist, but limit f of x extends to c minus not equal to limit f of x extends to c plus. So this definition says that function f of x has ordinary discontinuity as x equal to 0 if the left hand side limit of function f of x and right hand side limit of function f of x both exist but they are not same. In this case the function f of x has ordinary discontinuity of first kind. So we note here that if limit of f of x extends to c minus is not equal to f of c, then c is called as point of discontinuity from left. Then c is called as point of discontinuity from left. And if limit of f of x extends to c plus is not equal to f of c, then c is called as point of discontinuity from right. So let us take one example on ordinary discontinuous function of first kind. Let us write the question. Check the continuity of following function. So function is given to be f of x is equal to e raised to the power 1 upon x divided by 1 plus e raised to the power 1 upon x. The function has this value when x is not equal to 0, and function has value 0 when x is equal to 0. So let us write the answer for this question. Consider the limit of f of x extends to 0 plus. So right hand side limit, it is equal to limit x tends to 0 plus of the function e raised to the power 1 upon x divided by 1 plus e raised to the power 1 upon x. So see here, let us take x is equal to h is greater than 0. As x tends to 0, h will also tends to 0, but h is approaching towards 0 from the right hand side. So it is equal to limit h tends to 0 e raised to the power 1 upon h divided by 1 plus e raised to the power 1 upon h. Okay, and it is equal to limit h tends to 0. Okay, just we can put here. So what we have to do is just divide by e raised to the power 1 upon h in the numerator and denominator. So numerator become 1, here it will be e raised to the power minus 1 upon h plus 1, and it is equal to limit h tends to 0 1 upon, so just put the limit now as h tends to 0. So 1 upon e raised to the power, so it is not necessary to write the limit once again here. Okay, so here it is a by mistake. So directly we write it is equal to 1 upon e raised to the power minus infinity plus 1. So minus 1 upon 0 means minus infinity, and e raised to the power minus infinity means it is again a 1. E raised to the power minus infinity means e raised to the power minus infinity has value 1 upon e raised to infinity. E raised to infinity is infinity, 1 upon infinity is 0. So it is 1 plus 1 upon 0 plus 1 is 1. So this limit has value plus 1. Okay. Now let us consider the limit of f of x is changed to 0 plus is equal to 1. And now consider the left hand side limit f of x is changed to 0 minus. Okay. So in this case it is equal to limit x tends to 0 minus it is equal e raised to the power 1 upon x divided by 1 plus e raised to the power 1 upon x. It is equal to limit h tends to 0 e raised to the power minus 1 upon h divided by 1 plus e raised to the power minus 1 upon h, as x is equal to minus h. Here also h becomes greater than 0. Okay, as x tends to 0, h will also tends to 0. It is equal to limit h tends to 0 e raised to minus infinity divided by e raised to minus infinity plus 1, and final answer if I take it is equal to, it becomes a 0. It is not necessary to write the limit here. If I take a limit, then we have this value, and this value is nothing but equal to 0. So here also we say that the limit of f of x tends to 0 minus is equal to 0. Okay, so thus the right hand side limit is not equal to left hand side limit. Okay, thus this implies it is equal to f of 0 is equal to 0. Okay, this shows that the function f of x has ordinary discontinuity of first kind. Ordinary discontinuity of first kind. So now let us stop here, and thank you for paying attention.